Hello techies, today we are going to discuss the problem next closest time. This problem has been asked by Amazon, Facebook, Google and Microsoft interviewers, and this has been a favorite problem. So let's start the problem discussion. The problem provides us with the time that is in format HHMM, which is hour and minute format, and it is a 24-hour format. So and it wants us to provide the next closest time. So let us say we are given the time in this format. We are given 16:38. So to get the next closest time, we need to have all the characters in the we can use all the characters present in the time 1638, and we can use any character any number of times. So you can have 1138 created from it. You can create 1318. You can have 1831. You can have any number of possibilities. Now you need to find, and there can be more possibilities, and one possibility could also be 1811, which is the next closest number to this value. So the answer for this would be 1638 would be 1811. So this is the next closest number to the given time. Also, since as I mentioned that the time is in format 24 hours, so the maximum value you can have is 2359. What if you are given this value 2359? The next possible value would be next possible value could go to next day. So the answer for this would be 2222, which is going to the next day is 2222 hour. Okay, and we should also understand that there are certain possibilities, there are certain limitations to this time. What is the maximum value or time this time could have? So we can have the maximum values we can have is 2359. So let's call it h1 h2. Let's call this n, because this value is m1 and this was m2. So m2, the last minute value can have 0 to 9 values. The number could be 0 to 9. This value m1 could have 0 to 5, because you can never have a value like 62 minute. You can never have value like 62. Okay, so and let's talk about the limitation for h2. For or you can have you can have values like 22 21, but you can never have values like 29. You can have values 19, but you cannot have value 29. So it all depends on the previous value h1. H1 can have values from 0 to 2, and if a value of if h1 is equal to 2, then h2 can range from 0 to 3, and else it can have any values from 0 to 9. So this is a condition that we should keep in mind while populating the values. Okay, now I think we got the problem. Now let's jump to the solution. So since we are looking for the next possible closest time we can have, uh, let's start with the brute force. Since we are given this example 1638, the brute force says that you can have the brute force solution is like you can add 1 minute to it and see if any of this character it exists. Like I add 1 minute to it, it becomes 1639. Now if I see whether it can it has, so 9 is a value that is not there in the list of characters that should be uh, available over there. So this is not a valid value. Then you use 1640. So 4 and 0 are not there in the list, so it is not a valid value. Then you create 1641, and you keep on incrementing values until you reach the next possible value, which is 1811, and you say that yes, 1 is there, 8 is there, 1 again is there, so this is a valid value. So the first approach is you are incrementing it by every minute. The second approach you can have is, since you know that at h1 h2 m1, m2 positions, you can have the possible values you can have is 1, 2, 3, 4. Okay, so here in m2 position you can have 1, 6, 3, 8, because m2 ranges from 0 to 9, so it can have all the values. M1 ranges from 0 to 5, so it can have this value. So m1 can have these two possible values, and for h2 the possible values are 0 to 9 also, if depends on the h1. So if h1 is 1, so you can have any number of values. You can have 1, 6, 3 and 8, and h1, since we know that it ranges from 0 to 2, so it can only have one value. So you can create, you are required in this second approach, you are required to create all the possibilities you can create from this. Let's say let's try to create a tree. So first change this value. For example, let's change this value. Like we see this, it could be one, either could be 1631, it could either be 1636, it could either be 1633, it could either be 1638. Then we can further explore, let's say this value. This value m1 could have 1 or 3. So it could be 16, it could be 1611, or it could be 1631, which is itself value itself. Okay, and similarly you can keep on creating lots of combinations via this. So for every position you can have maximum 4 number of options or 4 number of possibilities. So the number of combinations you would be getting is 4 to the power 4. That is actually n power n, which is an exponential solution, which is not very good. You're trying to create all the possibilities and then checking if that is the next value, that is the most closest value, and next. Okay, so this is the next brute force solution. Let me mention, these were the brute force solution that can be applied to the problem. We'll just be talking about the optimized approach, which can help reduce the time complexity of this problem. Okay, so when we say the time, when we want to reduce the time complexity of this, we know that we want to have the next possible value, next closest value, and to get the next closest value, we should start from the rightmost minute value, that is m2 value. So can we increase this value, and to which up to what extent can we increase the value? For this, just list down all the values we have. We have 1638. Now let's sort the value so that I can find which is the next largest value I can pick for this m2. When we sort this value, we get 1, 3 and 6, 8. We get the sorted list as 1, 3, 6, 8. Now every time I want to update any value, I'll be looking at let's say I want to find the next value to 8. I should be looking at 8 and the next value I should find next to it. So for sorting, you can either use directly sort method, or you can use, you can store this in a binary search tree, where every time you want to read the next value, it will just be off login operation. In my case, I would be using a binary search tree, which is in Java I'll be using a tree set which is backed by a binary search tree, and I'll explain the details later on. Okay, now let's see. Okay, we are starting from the m2 position. We are at this m2 position. We want to start from the m2 position. Now to start from the m2 position, the value is 8. Now let's see which is the value next, which is the next higher value to 8. We see that there is no higher value to 8. Since there is no higher value to 8, we cannot increment the value. So what we do is we get the lowest possible value that we can have over here. The lowest possible value in the sorted list we have is 1. So let's pick the first value from this. So let me write it down over here, 3, and the new value would be 1. So it was 8, but we didn't have a larger value, so we simply replaced it with a smaller value. Now Now this is done. Now we move forward to M1, which is 3 right now. So what is the next higher value to 3? In this sorted list, we see that 6 is the next higher value to 6. But since we know that M1 can only have values from 0 to 5, so 6 is not a fit over here. So since 6 is not fit, we again go to the smaller value, which is 1. So we can simply update this by 1. So this is also 1. Great. Now let's move forward to H2. Now look forward. What is the next value to 6? This is 6. Now we find which is the next higher value to 6, which we see is 8. So, and H2 can have values from 0 to 9 if H1 is less than 2. So we see that H1 is less than 2 and it is 1. So again, now we see that we have found a higher value, so we can simply update the value. And since we have found a higher value, we should stop that. We have found the next highest, next closest element, next closest time for this input. So 1811 is our answer, and this is how we reach the solution. Now let's jump to the code. Okay. Yeah. I do have created some of the utility methods, like it checks whether if it is already the highest value, if the current value is invalid, to check what is the range of every string, every position, that is H1, M1, right? That reset, which is integer value, which will having all the integer values. I call it sorted tree because it is helping me sort the values, and I get this hash. Let's call it tree set, and that is the initialization of my tree set done. Now I need to store the value from the string time, so I'll be creating an array of values which will be having all this characters. There is H1 and H1, H2, M1, M2. It will be having 4 records. Now the first step is populate values array, or let's call it int value array, because we are storing the values into C and into from time string. I'll simply do a 2-char array to get the values. I'm doing a for loop. Over the time string, and I read the character time dot caret. I read the character. So the values array would now be having values. Int values will have something like this: H1, H2, M1, and M2. These are the values I'll be having. And one more thing, that since time is having this semicolon, this colon, I need to ignore this colon. So if C is not equal to colon, I should move forward. Let's keep the value into the string integer. I'm storing character as integer, and since parseInt takes a string, I'm converting that to a string, and I am adding this value to my sorted tree, so that every time I add a new value, it gets sorted. I should have initialized something like this. I have y, which will sort the int values and populating the value. So int values is getting populated like this. Great. The next step over here is we need to populate the business logic. The main business logic we had is look for the we will starting from the last most element, and we will be getting, so this is the last most element, so we are starting from the M2 and then we can move forward to H1 towards H1. So right to left, so right to left movement is there. So we have this integer which is saying higher, which gets the next higher value to this value. Okay, before that should be in an array. So if I int will start from the leftmost element, which should be greater than or equal to 0, and I minus minus. Okay, and we are looking for a next higher value now. I ask sorted tree to provide me the next higher value, and I think this is the time to discuss why we have used the tree set. So tree set is Java's way of storing the values in a unique form. Tree set stores them into the ascending order, and also it is backed by it is a binary search tree. It is a balanced binary search tree, and the balance is done via red black like tree. So every time you read from tree set, it would be O of log n operation. Then moving forward with the method that I'll be using is a higher method. I'll be using a tree sets method higher, which returns me the next highest value. Let's say if I say higher of 3, I'll be getting the next higher value, which is 6. And there's another method that I have used is first, which will give me the first or lowest value, which is 1. Let's jump back to the code. So here I have asked for a higher value from int values. I'll look for the higher value. If higher value is, let's say there could be a higher value or there could not be a higher value. So if there is no higher value, we will simply do a check higher value is null, or if okay, when I say that if the value is already highest, I am checking if the let's say the last M2 is maximum value, that is 9, or if the M1 is already the highest value, that is 5, or the H2 is having already the largest value, which is 3, and similar thing for H1, which is 2. The maximum value is 2. So I have checked whether it is having all the higher values, and then we also check if the current value that we are going to populate in place of the higher value is valid also. So it does the same kind of check, the range check. If I put it in this position, ith position, and int values. So if there is no higher value, that is higher value is null, or it is already the highest value, or the new higher value that we have got is invalid, or let's say if it is 6 and we want it should be in the range of 0 to 5, then in that case we would be going for the first, which is the lowest value from the sorted tree. Else if higher is not equal to null, we can simply update the higher value and break the program. So when I say break the program, I am saying that stop the operation to yep. So we have placed the higher value to its position, and let's break the program because we are done. We already find the higher value. So our business logic is also done. Now let's repopulate the output string, or I should say the populate the output string from int values. So we will be iterating over all the values into the int values, and we will populate the values accordingly. And yes, I am using a string builder in Java. String builder lets you append string in a much optimized way. I call a sb.append method, and which append into values of I, and if yes, we also need to append the colon. So if I is equal to 1, just append the colon. That is it. It should be SB. Now this is done. I should simply return SB dot to string. Yep. Lower value should be also be replaced with this, and yes. Now let's run the use case and see if that works. Yes, all our logic is accepted. Let's submit the problem. Super, the solution has been accepted. And so thank you so much. See you in the next video. Goodbye.